that we want to talk about.
Yeah.
When we draw these graphs, we know that technically, put the rulers down. I can't stand looking out and seeing rulers flying around everywhere. Stop it. Okay. When we graph sine and cosine, they keep going forever, right? Because you can just keep going around the circle. We've talked about coterminal angles, and you could go backwards. You could have negatives. So it never really stops. So they are what we call periodic functions. They repeat every certain bit of time. And in fact, they repeat when you go all the way around the circle. If you go all the way around the circle, what angle is that in radians? 2 pi. So sine and cosine are periodic functions with a period of 2 pi. The period is how long it takes until they start to repeat themselves. So just like anything else, if you're going to graph something for the first time, we've always made t-charts, right? On your little paper, I've kind of set up a t-chart for you. I just flipped it on its side. So I went horizontal instead of vertical. So we are going to start by graphing sine. Our angle, like our theta, that's what the x-axis represents. So this is 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi. What are these points? Pi over 2, pi, 3 pi over 2, 2 pi. Right, it's every 90 degrees if we're talking about the unit circles, those points on the x and y axis. So we know we can always pick more points if needed, but this is going to get us started. All right, then our y is sine. So if you think about the unit circle, on the unit circle, x is cosine and y is sine. So you could either think about what is the sine of 0, or if you think about on the unit circle, the y value is 0. At pi over 2, so you could think what's the sine of pi over 2, or you could think on the unit circle, the y value is 1. At pi, what's sine? At 3 pi over 2. And 2 pi, you're back to 0. So let's plot this. I'm going to say this is 1 and this is negative 1. So we have 0, 0. Pi over 2, 1. Pi, 0. 3 pi over 2, negative 1, and 2 pi is 0. Alright, we have a pretty good idea what this graph looks like right now, but don't go drawing in a zigzag quite yet, because it's actually not something like this. It's a curve. We could get that if we put in a few more points. You don't have to, on your paper, once we learn the pattern, we're only going to go with the main points that we need. But for this first time, if I wanted extra points, you know, halfway in between 0 and pi over 2 is pi over 4. What's the sine of pi over 4? Radical 2 over 2. If you plug that in the calculator and get me a decimal, radical 2 over 2 is approximately what? Like 0.7 maybe? Square root of 2 divided by 2?
0.707.
So it's a little more than a half. Now, a third of the way through would be 30 degrees, or pi over 6. What's the sine of pi over 6? 1/2. So I can see right now it's not just as zigzag. If I did 2/3 of the way, that's pi over 3. That's radical sine of pi over 3 is radical 3 over 2, which is like 0.86 maybe.
0.86.
So you could put in those extra points, but I'm just showing you, putting them there to show you this is curved. It's not a line. Okay? And it just continues. It's sine and cosine look like waves. That one's a little bit off. So please, No, it's for when you do examples in your notebook and you want to draw an x and y axis. So please attempt to make these curved, and it should be nice and symmetric. You know, I give you quite a bit of grace when I'm grading papers, but if I see something like this, that is not correct. Okay? And I also shouldn't see something like this. They should be about the same size. It's a nice smooth curve. Now, does it really stop when I get to 2 pi? No. Then it's back to 0, so it would do the exact same thing, right? On your paper, you can leave it like this so that you know what the basic graph looks like. But I'm going to talk about domain range. I know it's just going to keep repeating itself, both directions. So domain, that's the possible x's. Is there anything we can't have? No, so my domain is range. We've talked about domain and range of these trig functions before. If I'm looking at my y values, what's my lowest? -1. What's my highest? -1 to 1. We did that back in chapter 1. We had domain and range for these. Are you good? So we can get those from the graph.
Oh.
Okay. Let's talk about cosine. So, my common angles for cosine. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Alright, let's get our y's. So we can think about our unit circle. What's the cosine of 0? 1. Cosine of the x. At pi over 2. At pi. At 3 pi over 2. And 2 pi. So on my graph, this is 1 and -1. Cosine of 0 is 1. Pi over 2 is 0. Pi is -1. 3 pi over 2 is 0, and 2 pi is back to 1. Just like sine, we could put in more points to prove this, but it is curved. So it should look like that. All right. Again, does this just stop when I get to pi over 2? No, it's a wave. It's going to keep doing the same thing. It looks a lot like sine, doesn't it? It's just starting at a different point. They both just bounce back and forth between -1 and 1. So what's my domain? And my range? Okay. Any questions on how I've gotten these? So here is my next question. Are these functions even or odd? This requires us to think back to algebra a little bit. Remember even and odd functions? Oh. I know somebody taught you that. So even functions, that means symmetric to the y-axis. Odd means symmetric talking about if I flip my graph over the y-axis of the origin, do these things overlap? This is going to be very important. Probably won't come up in our graphs today, but tomorrow it would be very useful if we remember this. So let's look back at our graphs that we have drawn. I look at the graph of sine. If I fold this thing over the y-axis, does it overlap itself? No. If I fold it over the y and then over the x, would it overlap itself? Yes. That is the definition of odd. And what that means is if you have a negative x value, you get the opposite of when you have a positive x value. And I would strongly recommend writing that statement down, sine of negative x equals negative sine x. That was the definition of odd that we had in college algebra. But it is going to be very useful when we get to graphing this. Now let's look at cosine. So take a look at your cosine graph and decide, do you think that would be even or odd? Even. Assuming I were a decent artist. If I flip this over the y-axis, would it overlap itself? Yes. So cosine is an even function. The definition of even says if you have a negative on your x, you get the exact same thing as when you have a positive on your x. Because it's the same y value on both sides. Questions for me so far? So now we're going to draw some more graphs, but we're going to go to our notebook. We're going to look at variations of sine and cosine. Let's not do this one. I'm going to do this one. To graph y equals 1/2 cosine x. We're doing it in our notebooks, and we're going to compare it to the regular cosine. Alright, so let's draw. You have rulers, so you can draw yourself a nice x and y axis. And everybody has a ruler, whether you want it or not. Okay. On our x-axis, we are going to put like the quadrants or the main points when we go around the unit circle. So we start at 0, then after 90 degrees it's pi over 2, another 90 degrees that's pi, 3 pi over 2, and 2 pi. Remember, the distance between each of these is 90 degrees, so they should all be evenly spaced out. You don't want to have, two of them really close together and then your last one. So please, on your x-axis, make every attempt to space those even. When I'm graphing cosine, it started at what value? 1. Okay. So the cosine that we already graphed, we said the cosine of 0 is 1. And then if you remember the pattern, you can just fill it, it's going to hit 0, -1, 0, 1. Or we can think about it. Cosine of pi over 2 was 0. Cosine of pi, -1. Cosine of pi over 2 0. Cosine 2 pi is 1. So I'm graphing just regular cosine for a second. And that's what we had on our handout for what cosine is. So let's talk about what happens if I want to graph 1/2 cosine x. If I put in 0, cosine of 0 is 1 times 1/2. 1/2. Cosine of pi over 2 is 0, right? Times 1/2 is still, think about on your unit circle, cosine is the x. So when you're at pi, your x is -1. 1/2 times -1. Okay, 3 pi over 2. If you're thinking about the unit circle, your x is 0 times 1/2 is still 0. 2 pi, you're back where you started. Cosine is 1 times 1/2 is. So here's 1/2 cosine x. So what changed? Yeah, it was a vertical compression. You remember stretches and compressions in pre-cal or college algebra? That 1/2 made it get shorter. So what do you think would happen if I put a 5 out in front? It would stretch. My high point would be at 5, my low point would be at -5. Okay, so if you multiply a number in front, it's stretching and shrinking, just like we've seen before. With these trig functions, it's sometimes called something different because these are waves. Does anyone know what like high and low points on waves are called?
Maximum.
They're the maximums and minimums, yes. And the distance between those is called the amplitude. So a lot of times you'll hear me say amplitude, that's how far is it between the maximum and the minimum values. So, with sine and cosine, a number in front gives us the amplitude. Amplitude is half the difference between the maximum and minimum. I'm saying it like that, the half the difference, because eventually we'll move these graphs up and down as well. So, yes, as long as you don't move your graph up or down. So for now, it is just the distance to the x-axis. So I want to graph y equals sine of 2x. So the difference is the 2 is attached to my angle here. So I'm going to place on the x-axis, evenly spaced, we do 0, pi over 2, pi, 3 pi over 2, and 2 pi. If I put in 0, sine of 0, sine is your y value. What's the sine of 0? So 0, 0 is the first point on my graph. When I put in pi over 2, order of operations says first we have to multiply. 2 times pi over 2 is pi. What's the sine of pi? Sine is the y, which is still 0. Okay, if I put in a pi, order of operations, 2 times pi is 2 pi. Sine of 2 pi is, I did 3 pi over 2, that's 3 pi. So there's 0, 1 pi, 2 pi, 3 pi. What's the sine of 3 pi? If I put in 2 pi, 2 times 2 pi is 4 pi. What's the sine of 4 pi? 0. However, I think it's very unlikely that the graph of sine just turned into a horizontal line.
It's like
Let's try something in between. What would be halfway in between 0 and pi over 2? Okay. So if I plug in a pi over 4. 2 times pi over 4 is pi over 2. What's the sine of pi over 2? 1. So pi over 4 gives me 1. Okay. This would be 3 pi over 4. So 2 times 3 pi over 4 is 3 pi over 2. Sine of 3 pi over 2 is, so at 3 pi over 4 I'm getting negative 1. Can we tell what it looks like now? And it's just going to keep following that same pattern. So here at pi it's at 0. So it's going to go back up to 1, back to 0. Negative 1, 0. So what did that 2 do to my graph? It was a horizontal compression. So a number on the inside will stretch or shrink. Horizontal does the opposite of what you think. You compressed it in, that's why it got shorter, or it's repeating faster. So what do you think would happen if I put a 1/2 here? It would stretch it out. So this number inside, again, when you're talking about waves, we don't necessarily talk about stretching and shrinking so much. What it did is it changed the period of the graph. Remember, the period is how long it takes to start repeating. Sine normally repeats after 2 pi. But how soon did this one start repeating? After pi. So to find the period of the graph, if you have sine or cosine, you take the normal period 2 pi and divide by the number multiplied with x. We could graph every single trig function by making a t-chart, but that's time consuming and somewhat unnecessary because their graphs are so similar. The graph of sine is always going to look the same. It's starting at 0 and just bouncing back and forth. Cosine is always going to look the same. It's starting at its high point and bouncing back and forth. So if we recognize these patterns, it can shorten the process for graphing. So for graphing our trig functions, it's not just sine and cosine, it's for all of them. Here's what we are going to do. The very first thing, so when we graph these, I'm going to make a list of information out to the side. The very first thing I'm going to ask you is, what is the amplitude? Then we're going to find the period. Third thing is what we count by, and I'll show you how to find that in just a second. And then we will plot our points and sketch our curve. So here is our problem. We are going to graph y equals 2 sine of 3x over 2 periods. I might just do 1 period to start with. I'll do 2 tomorrow. How about that? Unless you want me to do 2. Then I'm happy to. Okay, so what we're going to find, amplitude, period, I just put CD, count by. We're going to do that on every problem, the very first steps. Where do we find the amplitude? Whatever number is out in front. So my amplitude is 2. What that tells me right now in terms of my graph, my high point would be at positive 2, my low point would be at negative 2. All right, the next step, period. How do we find period? Yeah, it's 2 pi divided by the number with x. So 2 pi over 3. Reduce that if you can. We can't here. So my period is 2 pi over 3. That means if I'm graphing one period, it's going to start at 0 and it'll end at 2 pi over 3. Now, that also means my points aren't just the nice 0 pi over 2 pi, 3 pi over 2, right? That's where this count by comes in. So this count by, this will give us the points on the x-axis, and we're always going to do it by taking our period and dividing by 4 for the 4 quadrants. Okay, so when I look at this, my period is 2 pi over 3, and I want to divide that by 4. Now, fractions confuse you. You can use a calculator. Don't put in the pi, just do 2/3 divided by 4 and give it to me as a fraction. And you get pi over 6. Okay. That's where I'm going to plot my points on the x-axis. So, we start at 0. Then we are going to add the count by. So plus pi over 6 is pi over 6. If I add pi over 6 again, that's 2 pi over 6. Right, but we want to reduce, so that's pi over 3. Okay, if I add it again, that would be 3 pi over 6, which is, we want our starting point and then 4 points after that for the 4 quadrants, because we want to get back to where we began. So if I add pi over 6 again, that's 4 pi over 6, which is, where have we seen 2 pi over 3 before? That was our period. Yes. So our one period ends at 2 pi over 3. Alright, at this point, if you know what sine looks like, the graph isn't too hard to fill in. Where does sine start? At 0. Now, could I plug in pi over 6 and work it out? Absolutely. Or you could think, okay, does sine go up or down next? Up. And so at pi over 6, I have to be at my high point of 2. And then it's got to come back to 0. And then at pi over 2, it would be at my low point of negative 2. And back to 0. You're just bouncing back and forth between 0, high, 0, low. That's all you're doing. But if you get confused, plug in your point. If I put in pi over 6, 3 times pi over 6 is pi over 2. Sine of pi over 2 is 1. 2 times 1 is 2. So we can get them by plugging in. And then draw in a curve. Are there questions on that? We're going to practice a lot more of these tomorrow. Okay? I would do another one, but with less people leaving, I don't really have time. So I'm going to go ahead and stop here. But I will go ahead and put some props up. Yes? Okay. Sure. So pi over 2. You have to find the sign first before you multiply the 2 sides. All right. So we will do more graphs tomorrow. These problems, 1 through 12, are matching questions, so it's not nearly as much as it looks like. So you should be able to, at the very least, do 1 through 12.